All right, this is question number 16. We're asked, you're sending, or you're designing a coding system for data relayed by a satellite to make transition errors easy to detect. You can't have repeated digits, so that's important to know, no repeated digits. Part A asks us, if you need 60,000 different codes, how many digits should each code be? Okay, so the problem here is that, well, the fact that this is no repeated digits should kind of give us that idea of permutations, but we're told the answer. 60,000 is going to be the answer. We want to have 60,000 permutations, but we're not told how many things we should be permuting. We're not told how many digits we want. So we kind of have to go backwards. So let's say there's one digit. If we only had one digit, numbers 1 to 10, how many codes would we have? Well, can I use 0? I'm going to assume I can use a 0. And I can't use 10 because that would be 2 digits. So I could have 10 codes. 1, 2, 3, 4. I can't have 10 and 0. So I could have any of these 10 numbers, but that's it. So if I had 2 digits, I would be permuting 2 objects. The first could be any of these 10 numbers, and the second could be any of these numbers, but not the one I used for this one, so it's down to 9. Okay, that would be 90 signals. Not enough to get me to 60,000. 3 digits would be 10 times 9 times 8, which would equal 720. And again, far short of the 60,000. So now you're just going to keep adding to this, right? 4 digits. We're just going to keep adding a digit until we get a product which is at least 60,000. Okay, so let's do this on a calculator. So 10 times 9 times 8 times 7 gives me 5,040. So that was 10 times 9 times 8 times 7. Obviously not enough to get me to 60,000. So let's just add another digit. Let's add it times 6. Does that get me there? No. Times, sorry, not 7, times 5. Does that get me there? Yes, that's above 60,000. So I need to go all the way down to times 5. Okay? So I need 10 times 9 times 8 times 7 times 6 times 5 equals, what was it? 151,200. So this is bigger than 60,000. Well, way bigger than 60,000. Okay. So how many digits did I have? 1, 2, 3, 4, 5, 6. So therefore, 6 digits are needed. Okay, so you need 6 digits to get at least 60,000 codes. And actually, that'll get you way more than 60,000 codes. That would get you 1,200 codes. Okay, part B. How many 10-digit codes can you create if the first 3 digits must be 1, 3, or 6? Okay, so part B. We need 10-digit code. Okay, so there's 10 digits. So 10 spaces that need to be filled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first one, there's only 3 options, right? It can only be 1, 3, or 6. So we only have 3 possibilities. Times, now the second one can be anything that wasn't used in the first one. That wasn't the 1, 3, or the 6, whichever one we put there. So we have 9 possibilities. 8, 7, So we have 3 times, and then this whole thing you could just write as 9 factorial equals whatever that equals. That's your answer. So you would write, therefore there are, however many that is, what's the question? 10-digit codes. So this number would be whatever that is, whatever that comes out to on your calculator.